Student, in this lecture I will discuss about the construction rules of root locus plot, okay, or the procedure for plotting root locus. Okay, so I will discuss step by step how we will draw root locus. Okay, so see the first point. First is the starting point. So the root locus starts from the open loop poles when k equal to 0. Second is ending point. So we know the root locus terminates either on open loop 0 or infinity when k equal to infinity. Okay. Third is number of branches. The number of branches of the root locus are capital N equal to capital P if P greater than Z, or capital N equal to capital Z if Z greater than P. Here P is the number of pole and Z is the number of 0. So we know usually always P greater than Z, therefore N equal to P. Okay. Now see the fourth rule. Fourth is the existence on real axis. The existence of the root locus on a section of real axis is confirmed if the sum of the open loop poles and zeros to the right of the section is odd. Okay. Now see the fifth point. Fifth is breakaway point. So how we find the breakaway point? On the root locus between two open loop poles, the roots move towards each other as the gain factor k is increased till they are coincident. At the coincident point, the value of k is maximum as far as the portion of the root locus between the two open loop poles is concerned. Any further increase in the value of k breaks the root locus in two parts. The breakaway point can be determined by rewriting the characteristics equation and therefore solving for the value of s from the equation like dk ds equal to 0. Okay. Now see the sixth point. Sixth point is the angle of asymptotes. So see, for higher values of k, the root locus branches are approximated by asymptotic lines making an angle with the real axis given by 2k plus 1 into 180 degree divided by p minus z, where k equal to 0, 1, 2 up to p minus z minus 1, where p is the number of pole and z is the number of 0. Okay, so this k somewhere mentioned q. Okay, so k and q are the same. Now see the seventh point. Seventh point is intersection of asymptote on real axis. The asymptotes intersect at a point x on the real axis given by x equal to sum of pole minus sum of zeros, and this divided by p minus z. This sum of poles, here we consider only real parts of pole, and sum of 0, here we consider only real parts of 0. No complex part. Okay, only consider real part. Now see the eighth point. Eighth point is the intersection points with imaginary axis. So see, the value of k and the point at which the root locus branch crosses the imaginary axis is determined by applying Routh criteria to the characteristics equation. The roots at the intersection point are imaginary. Now see the ninth point. Ninth is the angle of departure from complex pole. Okay. So see, the angle of departure of the root locus from a complex pole is given by phi d equal to 180 degree minus phi p minus phi z, where phi p is the sum of all the angles subtended by remaining poles and phi z is the sum of all the angles subtended by zeros. The angle of departure is tangent to the root locus at the complex pole. So, when we calculate angle of departure, so if in our open loop transfer function, if there is complex pole or zero is there, then we consider this angle of departure, or we find the angle of departure. If complex pole or zero are present in the open loop transfer function, then we will find angle of departure. Okay, otherwise need not to find the angle of departure. If there is no complex pole in your system, so no need to find angle of departure. Okay, now see the 10th point. Now see the 10th point. 10th point is the angle of arrival at complex zeros. Okay, so the angle of arrival of the root locus at a complex zero is given by phi a, and this phi a is equal to 180 degree minus phi z minus phi p, where phi z is the sum of all the angles subtended by remaining zeros and phi p is the sum of all the angles subtended by poles. The angle of arrival is tangent to the root locus at complex zero. So, when we calculate angle of arrival and angle of departure, if there have complex pole and zeros, then we will find angle of departure for complex pole and angle of arrival. We will find angle of arrival if there is complex zero present in the system. Okay, so the steps which I have discussed are sufficient to plot the root locus for a given open loop transfer function. The calculation of the value of k at a specified point on the root locus, determination of damping ratio zeta, assessment of time response and stability, etc. are illustrated in the solve example, which I will discuss in next lecture. Okay.